Okay guys, welcome back to Learn Mathematics Today with the Great. So in the previous video we talked about the gradient of a straight line graph. So if you've not watched the video, feel free to go back and take a look at it. So in this video we'll be talking about the gradient of a curve at a given point. So if we also take a point P and Q on a curve and calculate as we did for the straight line, let's me draw a curve and let's zoom. This is a curve. I'm not that good with sketch. Okay, this is our x-axis and y-axis. So if put on a curve this way and I pick point P, another point Q, so and we evaluate the vertical distance of the curve as it rises between the 2 points all over the resultant distance between the 2 points. So the result we are going to get will actually depend on the choice of P and Q, as this can be seen from this curve. So if P is here and Q is here, the result will be different from if P is here and Q is here. Now, why? This is because the gradient of the curve varies along its length. Because of the gradient of the curve is not defined between 2 points, as in the straight of when compared with straight line, but at a single point. So the gradient of a curve at a point is defined to be the gradient of the straight line that touches the curve at the point. So the gradient of a curve at a given point is defined to be the gradient of the line that touches the curve at that point. Enough of story, let's look at how it looks like. So this curve looks good. This line. Okay. Now let's pick a point P. Let me call this point P. Okay, and draw a line that passes through this point. So a straight line, straight line, straight line, straight line, straight line. You are not straight. Okay. So now we can only find the gradient at this particular point, which is going to give us a different value at other points. So the gradient at this point P is equal to the gradient of the tangent to the curve at P. So this looks straightforward, but it's very important because all of the differential calculus depends on it. So you can write it down somewhere. Now, how do we find the gradient of a curve? So let's assume this curve here is a curve of y equals to 2x squared plus 5. So if we want to sketch this curve, conventionally we how to use a graph sheet. So I'm going to have my x-axis here. I have 0, 0.5, picking my scale on the x-axis, 1.0, 1.5, 2.0, 2.5, and 3.0. Okay, so I'm going to write my 2x. Let's start with x squared, then 2x squared, then finally 2x squared plus 5, which is the value of y. So when x is 0, if we put 0 inside this equation here, we are going to have, let's use another color. So I'm going to have 0. Same thing for 0.5. I'm going to have 0.25 or 1.0. So this is the final value of what we calculated. So using the scale of x to be 0, 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. So this will be plotted on a graph before the final answer can be taken. So if you are told to find the derivative, so you trace it. Let me show you that. Let's have something like from this place. Okay, then yeah, so this is going to be your dy dx. So this dx and these are dy. So this is the approximation method. So let's look at the algebraic determination of this. Let me remove this. So if we have a curve this way, so let me draw the graph. Oh, almost good. So let's have a curve here. And a line. Let me give the line color blue at this particular point. Let's say point P. So a straight line. Okay. Let's call this point Q. Point Q. So if we, the same way, if we want to evaluate our dy dx, so point P where it stops here, Q here, that's our dy dx. But if we actually take a closer look and we trace this point Q downward, let me write our dy dx here. Wrong pencil. So this dy, this dx. So should trace this one down again. Now at this point we're going to have our delta y over delta x. Now notice that we use delta x and delta y to denote the respective differences in the x and y values at point P. X and y value at point P and Q on the curve. So we reserve the notation the x and the y for the differences in x and y values of the position of 2 points, a straight line and particularly for a tangent. The quantities the x and the y are called differentials. So let's quickly have something now. If y is a function of x, okay, and so if we should add this difference which we will use as delta y to this, and the one for x plus so now if I subtract y from both sides plus minus y, this will be f of x plus delta x minus y. So I have delta y left here, and this is f of x plus delta x minus our y here is y equals to f of x, so we are going to have f of x. So then after that, let's find delta y over delta x. Our dy dx which is the gradient can be gotten as the limit when delta x approaches 0 of f of x plus delta x minus f of x over delta x. So this is going to give us this. I will talk more about limits in our subsequent videos, and this expression will be applied in the next video. Please do well to subscribe to our channel and click the notification bell for you to be notified when the new videos comes out. I would like to take your comments. This is the first stage of the video I will be releasing, so I would like to know how you feel about it. Please feel free to comment, and till then, enjoy mathematics.